Hello everyone. So this is the first talk for the today, and we're gonna have around observe smarter, not harder, scaling AI-powered observability with OpenSearch. So today we're gonna discuss around like how you can do the observability on OpenSearch and maybe how you can use the end-to-end platform to tracing anything. Before we go, let me introduce ourselves. So I'm Aditya Soni. I'm currently working as DevOps Engineer 2 at Forrester. Before this, I was working at Red Hat, and I'm one of CNCF ambassador, speaker, mentor.
Okay, so good morning everyone. I'm Anshika Tiwari and currently I'm working as a cloud support associate in AWS, and previously I have worked as a DevOps engineer in RoboMQ. So moving forward, we will trace here like the history of observability. We will identify the key pain points, okay, and then we will be demonstrating how the OpenSearch model tool chain addresses these with advanced searches, analytics, and AI capabilities. Moving forward, let me walk you through the roadmap of AI-powered observability. So firstly, we will be looking upon the early days of observability. How the observability has begun, how it has introduced itself, and how people have started, like companies have started bringing observability into their teams. So moving forward, we will be looking at AI revolution from reactive to proactive. We will be examining the shift from reactive problem solving to proactive prevention using AI. Then we will be looking why OpenSearch is the answer. We will be introduce why OpenSearch as a powerful solution for modern observability needs, explaining the key features and advantages over traditional monitoring tools. Then we will see AI observability stack on OpenSearch. So that there we will be describing how different AI technologies can integrated with the OpenSearch for enhanced system monitoring. Then we will jump upon the observability data journey. Trace the path of observability data from collection to analysis. We will discuss data integration, processing, storage, and visualization in the context of OpenSearch. We will look AI-powered anomaly detection with OpenSearch. Focus on how AI algorithm and OpenSearch can identify unusual patterns and potential issues. We will see how vector and neural search can become the next frontier. We will introduce search techniques using vector embeddings and neural networks. We will discuss how these technologies are revolutionizing the data querying and analysis in observability. Then we will move forward with a small demo. We will have AI-powered observability depicting with OpenSearch. Then finally, we will be ending our session with best practices for scale and implementation, which offers a guidance on effectively deploying and scaling AI observability solution with OpenSearch and includes tips for optimal performance and avoiding common pitfalls. So let's begin and see what observability is. So if we begin and if we see at a higher level, observability is all about you bring clarity to chaos. So what is happening nowadays? Actually, there is a lot of data. And since we know that there is AI has boomed so much, the data ingestion has also increased enormously. So now observability becomes a must to have. We cannot just think about whether it should be there or not. So whether it is a small organization or an enterprise, observability has become the important need. So also I would like to share with you that the analysis performed by the logz.ai shows that just 1 out of 10 organizations are utilizing the full observability, while only 10% of respondents say that they have full observability today. That is observing the real-time status of every component of entire technology stack. So it means only 10% of the companies till now are completely using the observability. Still there, peoples are lacking behind, and this is the reason that we are not able to detect the different kind of different kind of issues at an early stage. So moving forward, we can see that only 36% of respondents feel they are partially started their journey, and with plans to add more capabilities, and only 20% are planning to even start now. So if we see, we are lacking a lot behind, because observability adds a more when it comes to identify an issue and to resolve them. You cannot have a large amount of days just spending to identify a single small issue that can be solved in few hours. So let's move forward and see how in early days the observability looked like. So in the early days, we could see initially observability relied mainly on command line tools, just as grep, awk, or custom scripts made by the engineers. So we are aware, earlier there were very few log files, since there were not much servers also. So engineers used these few commands that can be used to identify if there is any error or not. But this approach was slow, and it required deep system knowledge, and was more prone to human error also. So as we can see, the system has scaled, and these methods become more untenable due to the data volume and velocity from past few years. And therefore it leads to the limitations of slow incident response, high cognitive load, and error prone. While they are doing reactive troubleshooting, after making the service down or issue arise, they used to check the cause of that and makes that happen. So here what is happening? We are just waiting for the issue. Okay, so now there is the issue. Now our system has went down. So now let's now begin and look on. Let's now start to look on the logs. And earlier people were using just these small commands. That took a lot of time for the engineer to identify the actual cause. Later we can see there was a small automation added to that. That is rule-based monitoring. From manual to automated, but it was still limited, since we could see that rule-based monitoring like Negois or Zabbix automated some monitoring, but struggled with the false positive and couldn't adapt to the new patterns. Teams spent significant amount of time tuning the rules and dealing with the alert fatigues. But there were still some limitations, as there was lot of noise in the event data. So what happened? Even if the engineers have made the rules, were the rules exactly like were they correct? Were they correct for each and every environment? So that increases the noise in the alerts. There were a lot of alerts that was being pushed. So it definitely and which eventually lead to false positive. So the actual alert was being ignored by the engineers. Then there was another issue, which was ineffective correlation rules. What does that mean? Okay, engineers are working upon the rules to modify the monitoring, to modify the observability. Now what if different type of systems require different type of rules? Your different type of containers require different type of rules. So different type of logs will be pushed. How can you gather all that together? So you need to have a correlation rule that can be combined and can give you the exact result, but it was still lacking. Then there was a blind spot in data source. What if some container just went down? It came up and it suddenly went down. Was it able to push the logs? Was it the cause of the error? No, we couldn't identify that, because there need to be a rule that says, okay, fine, yeah, there was this error which was pushed by the container which has already gone dead, right? So this was the issue. Then finally there was alert fatigue. If large amount of alerts are being pushed, today we are aware that even if there are thousands or thousands numbers of alerts are being pushed, we cannot go to each and every alert. And finally, if we end upon things like, oh, it is a false alert, oh, it's a false alert, then finally there will be a moment when we will actually be missing the actual alert. We won't be looking at what is the actual cause because of which our system went down. So that was the reason that we were failing earlier. The traditional monitoring system was failing. Moving forward, what happened? The organization started centralizing and integrating different kind of tools for each use cases, such as for matrices, they use Prometheus, for dashboard, they might use Grafana, and more. And hence, centralized solution improved visibility, but that also introduced new challenges, like indexing bottleneck, slow query performance, and difficulty collecting logs and matrices and traces. So basically, even though organization moved ahead and they started to use different tools, but it was again also a lot of tasks to even maintain that tools, to keep an eye on that tools. What if the tool itself stops working? Then what? Okay, and even if to identify the actual root cause, you need to look upon each and every tool, because it is like for one tool you are using the dashboard, for another you are using the alerting, and like here in the diagram, as you can see, for matrices you might be using Prometheus. So okay, integrating them is fine, but again it leads to that you need to maintain all that tools together. So observability in the cloud era. Okay, challenges were there in microservices, containers, and distributed system. So if we see cloud native architecture, microservices increased data complexity and volume. We are aware that now I think everything comes on the cloud, right? So there are tons of containers running, there are tons of microservices that are running, and each microservices is pushing their individual logs, correct? And to identify the actual log between so many logs that from where we are actually getting the error becomes quite complex. Observability needed to handle dynamic environments, provide real-time insights, and scale horizontally. But there were still some limitations, as it leads to high cardinality. So what happened? Different types of logs were pushed from different containers, having different indexes, and to actually identify the actual cause from that becomes quite difficult. There were ephemeral workloads. So just imagine what happened if there were two containers that were running. One container just came up, threw some log, and it just got terminated. So how could you identify where the actual error was? Because the container itself is now terminated. So it becomes quite difficult to actually identify from where you are getting those errors. Then there is distributed tracing. So how different your microservices are distributed, how they are talking to each other. So it might be possible that one container is pushing some API to the other container, and we might be getting some error from the same container. So we might be thinking, but we are not able to see some error there. So we won't be able to identify the actual root cause, and therefore it leads to days of resolving a small error. Moving forward, if we see observability in the cloud era, so it feels something like this. If you look upon the image, it feels like, okay, finally the code has been deployed successfully to the production. Everything seems to be fine. Okay, moving forward, we can see, oh, it looks like something has wrong. CPU has just spiked in one of the containers. Oh my God, now logs are being flooded. Now what? How to actually identify the actual cause? Why is the CPU being spiked? Why it is being throttled? So now you need to look on the multiple logs and log files. So what happened? You can't trace the issue. You cannot detect some pattern. Okay, so just there is chaos. Your manager is just banging on your head. Okay, identify the issue. I want the resolution right now, but eventually it is going to take some time. So yeah, now it feels like this. Yeah, okay, we all are frustrated. So observability is still broken. So even we had tools from grep or even rule-based monitoring or centralized logging, still something was broken in traditional observability. If we look, first there has been an explosive growth in telemetry data. We are no longer dealing with the few files from monolithic servers. In today's world, with microservices, containers, and distributed systems, we are drowning in logs, traces, and matrices. Second, this leads to long mean time to resolution. What happened? Eventually, the engineers are stuck, scrolling through the endless logs, cross-referencing dashboards, and guessing the root cause. Blind spots become inevitable because no one can manually analyze every signal fast enough. And when you add alert fatigue into the mix with noise and irrelevant alerts, teams starts ignoring even the important ones. Finally, the traditional observability approach is reactive. It's not proactive. We wait for things to break first. Then we try to put the pieces together, what happened using disconnected tools and manual step. So it doesn't scale much. It is slow, and it often leads to firefighting instead of proactive prevention. So what happened when we say it is just a reactive approach? So eventually what happens, something just breaks down, then we react upon it. It's not just like that there is some AI or to identify the actual cause rather than just finding here and there. Then there can be some predictive alerting that we can set. So with this, if we look upon the proactive monitoring with machine learning models embedded into your observability pipeline, you can detect seasonal trends, even the sudden spikes or deviation in behavior without writing custom thresholds. Think of it like observability is watching itself. So even you need not to look for the observability. It is there to watch itself. So you are just free. You just need to react when it says you have to. Second, reduce the MTTR. Instead of digging through logs manually, AI can correlate logs, matrices, and traces to quickly suggest the likely root cause. Engineers can now get contextual alerts, not just what happened, why it might have happened. There might be fewer false positives. Traditional alerting often floods you with noise. So AI models, especially those trained with historical pattern, can filter out normal fluctuation and alert only when something actually deviates from expected behavior. So when it says false positive, so what happens if you train your model with your data, it will learn. So if it has been trained like, okay, 60% CPU utilization is fine for my containers. So it will be just, okay, it's fine. Someday it just spiked to 70 or 80. Okay, the AI will be there to tell you, just look upon that container. It might be down. It might get throttled. At some point it might get to utilized to 100%. So before that, your containers just eventually stop working and your service become unavailable for your users, you can just avoid the root cause on prior basis. So now let's see why OpenSearch is the answer. So I would like to call upon Aditya to help you further with this.
Okay guys, so thanks Anshika for the quite explanation about like how we came from like the previous era and then how OpenSearch can help us going forward. So if you see like all of the current tools that we are using, so those all are so much reactive. So that's mean like when any problem arises, you're just looking on the log. When you see like, okay, my response are getting slow, the latency is there, so on the time only you just go and check out the logs. But what if there is a way like you can be so proactive before even the problem is arising? So that's how we were gonna like dig in more today. So basically when you say about OpenSearch, so it will tell you more about like why and where to look. Okay, so logs are there, like things are failing, but it will trigger you the same thing like, okay, on the Slack or anywhere you want to notify, it will tell you like how you want to solve the particular issue. Okay. So if it look more about the OpenSearch, so this is like currently it's so famous, and then it's been years it's been used. So if you see like currently the project downloads around like more than 250 million. There are like if you see like it's top 4 search engine in the databases, and there are 70 plus partners, and that's actually growing now. If you see like the hundreds of new features and like that's coming in the newest version 3.2, there are lots of MCP and other lot of stuff that has came in. There are like you can use it on like on the cloud. It's on you, like you want to go with the Docker Compose types, or you maybe you want to use Helm chart, or how you want to do the installation maybe on the like your local host also. So you can do that. So moving forward, if you see like why basically OpenSearch is the answer, because OpenSearch naturally fits the AI observability narrative. So what's that mean? Since it's fully open source, so there is no vendor lock-in. Okay, you are installing it. You are, if you want to use it by your own, you don't want to use the managed version, or if you don't want to go with any particular tie-up, you can do that. Just install it by your own. You have to manage it by yourself. And later on, let's say there is no proprietary blockage when hosts scale. Today you are having around 10 users. Tomorrow you will be having around 500 or maybe 1,000 or more than that. On that time also, it's not something it's blocking you to scale. Okay, because most of the time what happens is like you are using a proprietary solution. You just ingest all the data there. After some days, they are just increasing the cost, and on that time you are stuck. What to do now? If we just migrate from here to another tool, then it will be another blockage for you. So that's what like again a solution for you. Log, metric, traces, ingestion at scale. So as Anshika said, like you are using like in the centralized logging, we were using Prometheus, Grafana, and different tools basically to having it all in one place. But with help of OpenSearch, you can have it all in under one roof. Built-in ML plugins. So with that, with help of that, like you can do anomaly detection. There are some AI search flows and a lot more things that you can do with the neural search also. And if you look more, then there are some integrations that's actually there. So let's say if currently you are using a tool, maybe Grafana, I would say, and your use case is like that, maybe you want to have logs in OpenSearch, traces in OpenSearch at the same time. Dashboard, you are saying like I want to be in Grafana, or maybe you are using OTel, okay, OpenTelemetry. So you are saying like, okay, I want to do OTel integration with the same, I want to do some maybe profiling or something like that, you can do that. There are some integrations available. At the same time, it's cost efficient because now it's on your hand how you want to scale it, how you want to run it, when, how you want to store basically the backups and all. Okay, so if we see like how AI observability stack on OpenSearch, so now we know like what's the OpenSearch, what's the observability and everything, but what are the main features or the main things that OpenSearch give you for the AI observability? The first thing is the OpenSearch assistant for OpenSearch dashboards. So there's a dashboard in OpenSearch that you get, and from the dashboard you can just go and you can check out the things like how your particular monitor is behaving, or maybe how the graphs is going. At the same time, you can integrate something like this. So if you see here, like we do have here the notebooks that's been created. At the same time, if you see in that side, we are having some that you can see it's like a chat bot, and you will see it's an OpenSearch assistant. So let's say whenever an issue coming in, you can just talk to him like you do as a ChatGPT or any other tool. Okay, so you can talk to him, you can check on the things like, okay, why this particular issue is coming, how to resolve it, something like that. So maybe if like I took an example here, maybe you can ask questions like what's causing latency spike last night. Okay, because last night you saw like there are some issues that came in, so you can just search on that. So that's the first thing. Then you have some observability plugins. Okay, so you can go on the dev tools in the OpenSearch dashboard. We will be having a small demo also. I'll show you quickly. So you can go to observability plugin. You can actually integrate a kind of plugin you want to have for your observability. So here, if you see, I actually tried with the ML commas, and I'm just using Hugging Face centered transformers. Okay, so that's how you can just integrate any plugins there, and that's how actually this will be deployed, and later on you can just use that with help of model ID and all. Then there's another thing came in picture, that's anomaly detection. So I would say that's the like that's my favorite feature, and actually this helps so good with OpenSearch. So it actually works on a random cut forest RCF algorithm. We will talk about that later. But if you see in the graphs, actually you are getting the anomalies. Maybe if you see here, the transaction per day is 149. And you want to set an alert, or maybe you want to have an anomaly, like maybe you want to set up something. If my transaction goes more than 155, then I should get an alert, or that should be scaled automatically, something like that. So you can do that with help of like OpenSearch. Okay, the next thing we're having is the AI search workflows. So AI search workflows is something like you have a lot of logs that's coming in, and you have created some index, or the data is ingested. Now what's your thoughts is like, okay, so instead of I dig in the particular logs, what I want is, what if I search for only error, but at the same time I'm able to get other similar warnings, or maybe other similar things that's not actually having error, but still that's actually helping the particular app to failing, something like that. So in the AI search workflows, you can use some ML models directly, and maybe that's the neural sparse, or maybe you can use them around Bedrock or any other stuff that should be having interface. Okay, so we'll talk that later. So with help of this, like you can just so if you see here, like currently in this particular ingest data, I have used ML inference processor, and I'm using Bedrock Titan embedding model. So in this, like after that, you have to just push out the text, or maybe let's say embedding which one you want to pass. Okay, so let's say in your logs, maybe your data is digesting with help of some input text, or you can see maybe some other stuff are there, timestamp, CPU, or whatever it is. So accordingly, you can just take your inputs, and you can share the outputs, like how that particular output should be stored. Then we have vector databases. So like for any AI application, it doesn't actually give you particular one type of log anytime. So it will be throwing sometime some text, some images, some videos, something like that. So and that's why like we are using vector DBs like for the AI application, and it's a must-have. And that works so well with the OpenSearch. Okay, so maybe like if you're having any application, maybe you're having any content, and what you do is like you just embed that first. So when I say embedding, so embedding is like maybe you are having a particular data, and then you are converting that to some numerical values to storing in the database. So later on, if you see like vector embedding, like it looks like this, and we just store it, and later on, whenever you are querying something, so accordingly the OpenSearch can show you the results. Then next thing we have is the data journey. So when you just push any data when you're ingesting, how that actually flows, and maybe I would say like how the vector actually created, and how OpenSearch actually read that behind the scenes. Okay, so for that, like maybe you can reference to this one. So the first thing is like your data is ingested, first thing, that's with the data prepper or fluent bit. So like these are some ingested that actually pull your data, or maybe just storing it. Okay, once that is done, you are just indexing or parsing the particular data. So on that time, you are just creating some index out of the logs. So let's say my logs is having some timestamp, some CPU uses, some tokens, something like that, and accordingly I'll create an index pattern, or I'll ingest the logs. After that, I'll be moving for anomaly detectors. So if you want to create those, you can do that. That's optional thing, and maybe you can search later on with the help of any vector search. So that's for this. And later on, let's say if you are having something like you want to build, maybe the ML model should detect issue as they happen for you. So for the same thing, you have to use for the AI search workflows again. And there you have to pass the queries like, okay, so which kind of particular pattern you want to select, or maybe you want to basically filter out later on. So this is for like the simple setup for the anomaly detection job. So the first thing you have to do is you have to create a anomaly detection job, and later on that particular job can have some the models that's embedded in. Okay, this one actually we missed previously. So as I said, like the random cut forest that actually used by the anomaly detectors. So what's that? So random cut forest is basically a unsupervised machine learning algorithm that actually by default OpenSearch uses for anomaly detections, and that's why it's so much of, like you can say, accurate whenever any anomalies you are getting than other tools. Okay, so it actually works on the two things. The first thing is the anomaly grade, and then confidence score. Okay, so after that, actually you can integrate some plugins and all with that. Then yeah, we do have some vector and neural search integration with the same. While doing this, you have to maybe like if you are getting an error like login failed or maybe authentication error. So maybe let's say if you are facing error like login failed, but neural sparse will also look for some errors like authentication error or token expired at the same time. Okay, maybe let's just move to the demo because we are just running out of time. So for the demo, what I'm doing here is, let me just move here. Okay, so hope it's visible. Yep. Okay, so if you see here, like what I have done is like I just wrote a Python API with a fast API, and that's where like I'm just integrating my OpenSearch Pi and OpenSearch to just push some logs. At the same time, it's just pushing to currently to 9200 port. That's where like the data is ingested. After this, if you see like I'm just pushing some kind of logs or maybe the data I want to ingest it in. So I've created all of this index pattern here, and then accordingly we will see the logs. Then we have some logger setup here. So with the help of loggers, we'll be able to get all of the logs there. And here I'm creating some I'm creating some 500 or this kind of error also by default. So accordingly, we'll see that in the OpenSearch dashboard. Then I'm integrating one of the model, that's the GPT-2 here with this particular use case, because we are using some tokens also, because later on, let's say if we are getting some spikes in the token uses and all, so I'm just creating some constraints. Okay, so my token use should be 2000 or something like that, 20,000, and then remaining tokens should be 100, something like that. And I do have some liveness readiness checks here, and then the app is starting. At the same time, I'm just generating some load. So with the locust, I'm just creating some random load here. With that, like actually we were able to trace some issues that we are getting at the real time. Okay, so if you saw this screen, so that's where actually this is the currently API calls are happening, and this is the locust that's actually generating the load for that particular API. Okay, and if you move to the OpenSearch dashboard, so that's the particular login dashboard that you get when you log in. At the same time, if we go to discover, we'll be able to see here the logs that's actually coming in from this fast API logs or maybe the matrices. So these are the logs that's currently digesting in from that application. And if we see the particular stuff here, like the timestamp, type, score, message module, so these are the same that we have passed for the logs to get in. It will be more correlative with the matrix if you see. So if you see here, we are using CPU usage, generation time, token used. At the same time, we have used the same stuff in the code to pass towards the OpenSearch dashboards. So we are getting only these stuff there. So once that is done, you can move towards the anomaly detections. So when you say about the anomaly detection, so currently I have made some of them, but if you want to build that, just come here, you have to just configure it with help of this, maybe predictive detector and results and all. So you can create your detector and you can just push whatever info it's requiring. Currently, let me show you like how I did one of the detector here. So we have a very fast API app that actually pushing some data regularly. So let me show you only last 1 hour data and let me update it. So if you see, we are able to see here some confidence and anomaly grade, and that's how like actually the anomaly detection works on the RCF algorithm. So here the confidence and anomaly grade we will be getting. At the same time, we are able to, I created one of the feature here for the CPU utilization. So we are able to see like how much CPU and my app is using. At the same time, I have created a particular monitor here that will send some alerts on the Slack. Okay, real-time alerts. So if you see here, I have created a trigger for the CPU utilization, and for this particular monitor, the destination should be over the Slack. That's I'll show you just after this. So yep. So here I have just created a webhook and integrated with the Slack. So whenever we are getting some anomalies, we are just it's just pushing the threads or the logs here. Accordingly, you can check like, okay, so how much token is used, how much CPU is spiked or something like that. So that's the one I would say. Apart from that, like there are the search flows. So there's as we talked about AI search flows. So that's one there. And in this, let me show you just quickly like what I'm doing. So we are just using some model, that's the Amazon neural sparse. that's being used here, and with help of that, you can just search that particular, basically in your ingested data, you can search the things. Okay, so once that is also good, you can maybe just export this and you can just reshare with your colleagues, or if you want to maybe create your own workflows, you can do that accordingly. So I guess we are running out of time, so maybe let me just move to the slides and complete what else was resting. So you can maybe optimize the cost and all with have some data work quality, model training and integration for OpenSearch. And while you are basically creating your observability checklist, so you have to aware about like maybe profiling, auto instrumentation and all, because in AI era, this is the must thing that you should be having in your bucket. I guess, yeah, that's all from this talk. Maybe if you have any questions, we are free to, feel free to ask them below the stage or maybe here.
Do you want to ask any questions?
Can you show how you build like anomalies, like what kind of rules you implemented?
Yep, sure. Do we have time for that? Yeah, sure. Okay. Okay. So regarding the anomaly detection, so let me show you again. If we go here again, just anomaly detection and detectors. So currently, if you see here, I just created 2 of them, but one of them is only running because that's where only the data is ingesting. Another one is initializing, but there's no data coming, so it will give some error because there is no particular data it will be able to find. Let's skip it and maybe move with the fast API one. So if you see here, so currently you will see like the real-time results, the first thing, because it's actually getting the real-time data here. That maybe you can see from just maybe 1 minute ago also. And if I update it, okay, it actually don't work for the minutes or something. At least you should have around hours of data, because it takes time to create all of the confidence and the grades. So that's how maybe you can take all of them, and then you have for the features and all. But as you said, like how you created the all of this, so one more feature is there for the historical analysis. So let's say you have some data, but at the same time that is stored now, but you want to check like how my previously, like how it impacted and how it behaved. So on that time, maybe you can check some anomalies for this. So if you see that there is one anomaly came in for, I guess, the CPU utilization only, and that's where we got the alert for the CPU. But apart from that, there were a lot of alerts we were getting for the what I would say, like the tokens used for the GPT one. Okay, so let me show you like how actually this is being configured. So I have to stop and we can just check it. So once you go here, so I'm just giving the name and the description. Then you can just use the cluster. So currently for me, it's the local one. And the index. So yeah, this is another part that actually I didn't show you, but this index actually directly created from the Python file actually I made. But if you want, you can just do it from your own. If you come here and then maybe if you just go to DevTools, you can create your own index with help of like how your data should be going, and then maybe you can manage that and create a pattern from here. You can just push what kind of index pattern you want to do, and that's all. So maybe let's say if I'll put here fast API, so I'm able to see like the fast API logs and metrics. So that's how you can create the index. So that's on that. I guess yeah, we are here. So then you can use the timestamp, because if your logs is having timestamp, so you can use that. So currently, yeah, I am pushing that too. So I've used that, and then you have the detector intervals. So currently I'm just detecting in a minute, or just window delay is also 1 minute. So in after 1 minute, it was just pushing some logs, and I can see that only. But usually it should be around some minutes, or maybe I would say some hours for you. So that's the detector, I would say. But apart from this, once you are just building it, you will able to integrate all of these things also, like at the starting features. So if I talk more about the features, so currently I created a feature for CPU utilization. So I enabled this feature, and I'm just taking CPU usage. So in this list, you will be able to see all of the field that you are passing from your application actually. So from application, I'm passing memory used, generation time second, token use, something like that. So this is actually used for the CPU, and accordingly it will give you, let's say if a spike is going more than 20% or like that, so it will just trigger something. So that's for this. And later on, one more thing is there. So once there's a thing like you want to create some alerts for this particular detector, so you have to go in alerts and you have to choose this one detector. So if I show you, I have one, okay, token and SIP utilization, this one. So this alerts is actually using anomaly detector, and that is being by that is being passed by the detector itself. So you can just check the detector from here, and then let's go. I hope that helps.
One
Yep.
quick question. So you here you used only the metrics. At the time of creating a detector, can you pass like metrics, traces,
Yeah,
logs, or
you can pass
all
both of them.
combined?
Yes, you can do that. So even there's a one more monitor I created. Let me show you. So for this, I have used logs and see if you see here. So I have used the logs and metrics, both of them, for this one. So yep, you do that.
So one more question.
So,
Shall can
so this is about automation, sorry, anomaly detection and normal monitoring, right?
Yeah.
Whenever you have to set any alert, you have to go monitor, you have to define the roles. And same thing, you have to do anomaly detection also. So what is the difference in both kind of monitors?
Okay, got it. So basically, if you're asking like if we directly create a monitor, how does it differentiate from the anomaly detector?
Yes.
Okay, so when you create a direct monitor, it actually works on like per query or something like that, and here you are getting a visual editor. Okay, and there are three options that you get. Okay, the one is the visual editor. So in visual editor, you can add what kind of things you want to have. But if you are having already a setup anomaly detector, and that is more precise because it uses RCF, and at the back end, it's like you have already created some features, as I showed you before. Like we created some features for the CPU and all. So this, when you're creating a detector, so you don't have to pass anything else. Just you have to push the detector name here. Apart from that, you have to only pass the trigger. That's the only thing like you have to pass. That's maybe if you want to get the notification on the Slack or something like that, you have to trigger it only. But if you're using apart from that any other stuff, then you have to pass the query and maybe some indices that you want to use, and later on you will be creating some triggers. So it's like you have some created some detectors for you, and for them detectors you want to have some alerts. So on that time this particular feature will be used. But apart from that, if there is a service like you are not having set up the anomaly detectors, but you still want to get some alerts from the monitors, so you can just go with the monitor setup.
So what I understood is monitors
we can
are
continue.
setting the,
So we have a session.
Yep, sure.
Hey, thanks,
Thank you so much.
folks.
Thank you so much, everyone.